Welcome! Today we're diving into something that can literally be the difference between life and death, machine safeguarding. It is an absolutely critical, non-negotiable part of industrial safety. And understanding it is the key to preventing some of the most horrific injuries imaginable in the workplace. So let's get right into it.
Look at these words. They aren't just abstract concepts, they are the devastating, gut-wrenching reality of what happens when powerful machinery is left unguarded. For so many workers, the line between a productive day and a life-altering tragedy is terrifyingly thin. This is the real human cost of inaction.
So how do we stop this? It sounds almost too simple, right? How can a simple piece of metal, or even just a beam of light, stand in the way of such powerful forces? Well, that's the core question we're going to answer today. We're going to break down the engineering controls, from the most basic physical barriers to really sophisticated electronic devices that stand between a worker and a life-changing injury.
First things first, this isn't just about being a good employer or doing the right thing. It's the law. The entire foundation of machine safety is built on a really clear legal framework. So let's take a look at what that actually means.
Okay, so safeguarding really boils down to two main ideas. First, you have a guard, which is exactly what it sounds like, a physical barrier. And second, you have a device, which is more of a trip mechanism that stops the machine if you get too close. These are the two fundamental tools in our safety toolbox.
And you know what? This isn't some newfangled idea. Just look at this. This requirement has been enshrined in Indian law for over 70 years. The Factories Act of 1948 is crystal clear. It doesn't suggest, it demands that dangerous parts be fenced off. This quote right here, this is the legal bedrock of everything we're talking about.
And the law does not mess around with vague language. It's incredibly specific. When it says substantial construction, it means the guard can't be some flimsy piece of tin. It has to be strong, it has to be constantly maintained, and, this is critical, it must be in position anytime that machine is in use. Ignoring these rules isn't just taking a risk, it's flat-out breaking the law, and the consequences can be severe, including things like factory closures and even prosecution.
Okay, so we've got the legal why. Now let's get into the practical how. The very first and, often the best line of defense is a simple physical guard. But there are different types, so how do you choose the right one? Let's open up the toolkit.
This table is a fantastic little guide. First up, you've got the fixed guard. Think of this as the vault door of machine safety. It's permanent, offering the absolute highest level of protection for things you should never ever need to touch, like whirring gears and belts. Then you have the interlocked guard. Now this is brilliant. It's a smart barrier. The second you open it, boom, it cuts power to the machine. This allows safe access for maintenance without anyone getting hurt. Next up, you've got adjustable and self-adjusting guards. These are all about flexibility for tasks where materials need to move, like on a bandsaw. They adapt to the job, keeping the operator safe without getting in the way.
But what happens when a permanent physical barrier just isn't practical for the job at hand? Well, that's where safety devices come in. These aren't just passive barriers. They are active mechanisms that are constantly monitoring the situation and can intervene to prevent an accident.
Now this is where the technology gets really, really clever. When you can't use a physical barrier, these devices step up. Take presence sensing, for example, like a light curtain. It creates this invisible field of light, and if your hand or anything breaks that field, the machine stops on a dime. It's incredible for high-speed, repetitive work. Then there's the two-hand control. I love this. It's a beautifully simple concept. The machine just will not operate unless both of your hands are on the controls, safely away from the danger zone. And finally, you have things like pullback and restraint devices that actually use tethers to physically prevent your hands from ever reaching the hazardous area in the first place. Each one is a specialized tool for a very specific job.
All right, all this theory is great, but does it actually work in the real world? Let's look at a case study from a manufacturing hub in India that shows just how profound the impact can be when you apply these principles correctly.
So let's put this into a real-world context. The situation was grim. There was an automotive stamping plant in Gurugram, and it was just plagued by severe injuries, especially finger amputations from these massive presses. The human cost was stacking up, and something had to change, and fast.
And what they did is a perfect example of smart, layered safety. They didn't just pick one solution off the shelf, they combined them. This is what we call defense in depth. So they used fixed guards for the transmission parts that no one needs to touch. They added interlocked doors for general access, and then right at the point of danger, they combined two powerful devices, a light curtain and two-hand control. And the results? Take a look at this, a 90% reduction in incidents.
Let that sink in. That one number, it says everything. It represents countless injuries that never happened, lives that were kept whole, and families that were spared from absolute tragedy. This is the life-saving difference we've been talking about. Of course, just knowing the solution isn't the whole story. Implementing these systems isn't always a walk in the park. There are real-world challenges, cost, productivity concerns, just plain old human behavior that you have to address to turn a safety plan into a true safety culture.
So, if this is all so effective, why doesn't every single factory have perfect safeguarding? Well, these are the real-world roadblocks. There's the initial cost, right? That can seem pretty daunting. Then there's the human factor. Operators might complain that a guard blocks their view or that it slows them down, and that temptation to just bypass it can be really strong. And finally, there's simple neglect. Even the best system in the world is useless if it's not maintained.
But here's the good news. For every single one of those challenges, there's a smart solution. Visibility issues? Use modern polycarbonate guards. They're as strong as steel, but completely transparent. Problem solved. Worried about people bypassing them? Don't just impose rules from the top down. Involve the people on the floor. Get the factory safety committee to help choose and implement the guards. When workers have ownership, they become advocates for safety, not adversaries. And to make sure you're on track, you can conduct regular audits based on Bureau of Indian Standards or BIS guidelines. See, with a little proactive planning, these hurdles aren't just manageable, they are completely surmountable.
And that brings us to the final fundamental question. After everything we've talked about, when we weigh the costs and the benefits, when we consider convenience versus the consequences, this is what it all boils down to. The answer, which is proven by law, by technology, and by the tragic cost of getting it wrong, has to be a resounding no. Because no product, no quota is worth that price.